In this video, we're going to look into how to fine-tune Gemma 3N. So this video we're broken down into 7 different sections. We're going to talk about how to install the models, make some inferencing with different modalities, loading the model for training, formatting our dataset in a specific way to make it ready for fine-tuning, and finally setting it to training. After that, I'm also going to give you guys specific scripts on how to save the model for both VLLMs and GGUF formats. Now, let's get into it. Now, first things first, you guys will need a Google Colab environment with a T4 GPU, and then install these packages over here. Over here, we're going to have Bits and Bytes, Accelerate Xformers, Unsloth, and a few other related packages to both make inferencing and fine-tune our Gemma 3N. Once we do that, now we can load our model for some quick inferencing using TextStreamer. So first of all, we're going to load the model. We are going to load this Gemma 3N 4 billion. Now, please make sure you guys have HF token on your environment available and make sure you guys have it like so. Now, while the model is loading, we're also going to define one other function using the TextStreamer package from Transformers. TextStreamer is a very nice way of generating inferencing using our LLM. Over here, we're going to wrap it in a function to make it easier for us because we're going to call the same function over and over again. So this is the do Gemma 3 inference where we're going to pass in our messages. This can be in either modalities and the max new tokens. This will be dependent on how big your GPU is and how much tokens it can generate. And with that, we are going to initiate model.generate, pass in the tokenizer with our messages or tokenize our messages, and then generate using our TextStreamer, which will generate tokens in real time, which is very, very cool to see. Now, first off, we are going to make inference on this image over here to explain what this image is and also how it's related to different films this animal is featured in. To do that, we will first need to pass it as a link like so. And then we're going to describe our messages, which will look like this. So we have messages over here, which is a list containing different JSON objects where we have a row, the content, including a list of different JSONs, passing in the image and the text like so. Once we've done that, we're going to use our nifty function that we just defined over here and start making inferencing. Now, this is actually really, really fun to observe over here, where the model is generating things in real time. So we don't have to wait multiple minutes until things start to generate. Although for this image over here, you may need to wait just a bit of time, but the generation can be seen in real time. And here we are seeing the generation happening in real time. This actually took more than 1.5 minutes to start kickstarting. Now that could be dependent on the GPU itself, making it quite slow. But nevertheless, we are actually processing an image-based prompt over here. So it's not too unusual. Now, what I really like about the Gemma 3N is that it can also handle mixed modality with inferencing. We can pass in an audio file, an image length, and a text prompt together. So let's try to do that. First off, we're going to download an audio file, and then using the exact same function, we're going to pass in the name of the audio file, wrap it in this JSON object inside of the content list with our text and image prompt, and do some inferencing. This may take some time, so please be patient. Now, surprisingly, this inference is way more faster than it was previously, even though it had 3 different data inputs as prompts. But nevertheless, we are seeing that it's processing and generating something in real time with the data input we provided. Now, once this is done, we're going to start to prepare our dataset for training. Now, to do that, the first thing that we will do is actually going to load our model using some parameters. We're going to pass in the model, fine-tune vision layers false. We're only going to fine-tune the text layer, fine-tune attention modules true, and fine-tune MLP modules to true, and then pass in some other configurations, like so. Now, if you want to know more about what these different things mean, please feel free to go into the Unsloth documentation to understand what these different parameters actually mean. Now, let's load the model. Now we will have to format our dataset. To do that, we're going to first load these 3 packages, get chart template, load dataset from the datasets package, and standardize data format. Now, it's actually quite amazing how Unsloth is so well integrated with Hugging Face, making things a lot more faster and efficient. We can load our tokenizer, get the chat template, and then load the dataset. We can use the fine-tune 100K, where we get 3,000 samples, and then we're going to format our datasets using the standardized data format package. This should go fairly quickly. Now, once that is done, we are going to define a function, which is formatting prompt function, where you guys may have to adjust this for your own dataset to have text in the final dataset we have. So we're going to map that. And then we're also going to select 10 samples because we don't want to train on the whole dataset. That could take way long time, which is not needed for this specific demonstration. And then finally, we will have a dataset with feature columns, conversation, source, score, and then text, which will be used for fine-tuning our model. Now, after that, we can start to define our training arguments, which will be used to train our model. Again, this looks very similar to any other fine-tuning video I've done previously, where we have the trainer from the SFT trainer from Hugging Face Transformers package. We pass in the model, the tokenizer, the dataset. And we can also have the ability to pass in the evaluation dataset if you guys have it. I highly recommend you guys have it. You guys can detect how your model is performing during the training procedure. And then we're going to pass in the config. This config will have which column we're going to use to train our model, what is the batch size, the gradient accumulation steps, which can be used to affect your model's performance, number of epochs, warm-up steps, max steps, learning rate, and other configurations. Now, it is highly advisable that you guys try different parameters and different combination of parameters to see which one adapts to your model or to your data well. Not only that, I highly recommend you guys use some sort of reporting function like weights and biases or TensorBoard to see how your model is performing based upon different configurations or dataset sizes. Now, let's define that and set up this intermediary step to train based upon different tags and then kickstart our training. And this will take various length of time based upon how big your dataset is and how many steps you guys used, and also based upon your GPU size as well. So nevertheless, we will have to wait until this model is being trained. Now, once you've trained your model, we will find a way how to save the model and hopefully upload it somewhere sensible. So you can either have save the model using all the weights together, or you can save it using the specific lower adapters which you just trained. So lower adapters are specific layers that you typically train or fine-tune that we did right now to make the training process efficient. And you have the ability to save specifically those layers, so you guys can save on a lot of different storage. So you guys can specify, like so, model.save pre-trained, and this will save the model with all the different weights or the entire weights. And you can also load the lower adapters from the base model and start making inferencing. You guys also have the choice to save the model using VLLM friendly format, using the 16-bit floating point, or saving it in a GGUF Llama CCP format, which can be used for, let's say, LM Studio inferencing. Alright guys, so that's a quick video on how to fine-tune Gemma 3N. I hope you found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. Alright guys, I hope to see you in my next video. Have a nice day.